Hey, today we're looking at 15-5, exploring overlap in data sets. For the intro, we're going to go over some vocab that you probably haven't seen before. The first of those is what's called the mean absolute deviation, and you'll see this in your notes. It says the mean absolute deviation is a measure of variability that describes how far the data values are spread out from the mean of a data set. So since we want to see how far they are spread out from the mean, first thing that we're going to have to do is calculate the mean. We need to know what that is so we can find the deviation. And think deviation, how far is it away? How far does it deviate? So first thing for finding the MAD, the mean absolute deviation, we want to find the mean. So the mean of this data set is 10. We find that by taking 7 plus 8 plus 8 plus 9 plus 10 plus 11 plus 11 plus 13 plus 13. And when we add all those together, we divide them by how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that gives us a mean of 10. So now that we have our mean, we're ready to find our deviations. We're ready to see how far away each of these data values is from that mean. And when we do absolute deviations, we're going to have negatives and positives. So we can see that that data point that was at 9 is -1 away. It's 1 to the left of the mean. I have two values that were -2 away, one that was -3 away, and then to the right, those are a positive amount of values away because we have 1 to the right for both of our values at 11, 3 to the right for both of our values at 13. Now once you have your deviations, you just want to see the average of how far all of these are away. So before we can do that, we have to get rid of all these negative signs so that we're just looking at positive values. So next we're finding the absolute deviations. So when we find the absolute deviations, think that we're finding the absolute value of our deviations, of our amount away. So all that we had to do was get rid of the negatives. Now if you haven't yet, take a minute to write down the deviations on your paper in the graph that's provided. So once we have our deviations all recorded, now we want to find the mean absolute deviation. It's exactly what you would think it would be. You want to look at all your deviations, 3, 2, 2, 1, 0 even. We have to account for 0, 1, 1, 3, 3, and we want to find the average of those to see about how far on average the rest of the data values are from the mean. So to find that, we're going to find the mean of those values. So we are going to add them up and divide by how many we have. So to do that, we see that we're adding 3, 2, 2, right here, 1, 0, 1, 1, 3, 3. We're adding all those numbers together and dividing by our number of data sets, or data values, so we're dividing by 9. So that means we're going to take 16 divided by 9, and when we take 16 divided by 9, you'll see that that gives you about 1.8 as your mean absolute deviation. And so what that's telling you is that on average, most of the data values are about 1.8 units away from our average, which is 10. So let's try some examples of this. Let's get our little video. So this says calculate the mean absolute deviation for the heights of second graders. The mean is about 50 inches, round to the nearest whole number. So we have a sample of 7th grade students and their heights. So we have a student who's 43 inches, and then we have values over here. Most of the students are in this range. And then we have a student who is a whopping 57 inches tall. So our first goal, like you can see on your paper, is to find the mean, because before we can find our mean absolute deviation, we have to know what our mean is. So take a minute to calculate your mean, and remember that each of these dots represents a data value. Okay, so now that you've found that the mean is 50, next we want to record our absolute deviations on the image. So I know that my mean is 50, so all those data values are my 4 data values that were at 50. I'm going to put 0 above them because all of them have a deviation of 0. Then for my values at 49, they were 1 to the left, so they all have a deviation of -1. Then I have -2 for my 3 values at 48, -3 for my value at 47, and -7 for my value at 43. And then the same thing occurs with all my data values on the right. So take a minute to fill out your data, to fill out your deviations on your chart. So now that you're finished with your deviations, you want to find the absolute deviation. So think taking the absolute value of all of your numbers. So really, all of those negatives just become positive. So take a minute to change your negatives into positives. So this is telling us the absolute value of how far away every single data point is from our mean of 50. So now that you've recorded those absolute deviations, we're ready to find the mean absolute deviation. So on your own, add up the deviations for each data value. So to start out, that would be 7 plus 3 plus 2 plus 2 plus 2 plus 1 plus 1 plus 1 plus 1 plus 1 plus 0 and all of your data values thereafter. And divide by how many data values you have. Do not forget your data values that have a deviation of 0 because we need to account for those 4 values too. So take a minute to find the sum and divide by your total data values. So finding that will give us, like we see here, they added up all their values and they even just multiplied by each of their deviations to account for 4 that were 1 away or 4 that were 0 away. But they added up all their values just like you did and divided by 25. So they took 48 divided by 25, which gave them about 2 when it was rounded to the nearest whole number like it asked us to do in the problem. So we find that the mean absolute deviation for the height of second graders is about 2 inches. So on average, all of the second graders that we see here are only about 2 inches away from the mean of 50 inches. So we're going to try another example just like this, but now with 7th graders. So now we can see that the mean is about 61 inches. So they're already giving us the mean. So on your own, take a minute to write down the deviations, negative or positive, for all your data values. Your values at 61 are all going to be 0. At 60, they're going to be -1 because they're 1 to the left. And then finish recording all the rest of the deviations. So now that you have your deviations, you're ready to find the absolute deviations for each of those data points. Which to do that, we just make all of them positive. So take about 10 seconds to change all your negatives to positive because we're looking at the absolute value. So now that we have all of our absolute deviations, we are ready to find the mean. To find our mean, we have to find the sum of all of our absolute deviations. So go ahead on your own, add up all your absolute deviations to see what you get, and record your answer in the space provided. Okay, now that we have the sum of the absolute deviations, we're going to divide by how many we have. And doing the math, we can see that we had a sum of 50, and then we had a total of 25 data values. So when we take 50 divided by 25, we get the answer 2. So we see that the mean absolute deviation for the height of 7th graders is 2 inches, just like we saw with 2nd graders. So fill in your answers as they're in the spaces provided on the screen or on your paper. So next we have an example that's asking us about example 1 and got it 1 on your paper. This reads, the graphs show the height distribution of samples of 2nd and 7th graders. Explain why the mean absolute deviations of both samples are the same. Now thinking about this, remember that mean absolute deviation shows you about how far away on average all the data points are from the mean. So in 2nd grade, the mean height was 50. And so when we found the mean absolute deviation, we said that on average, students are about 2 inches away from this mean. With 7th graders, their height was a lot higher. It was 61 inches. So when we found the mean absolute deviation, we found that on average, 7th graders are about 2 inches away from the mean absolute deviation. So because the mean absolute deviation, the MAD, shows us how far apart the data is spread, we see that the data for both dot plots is spread out about equally, which is why the MADs are about the same. So what this is showing is that regardless of if students are in 2nd grade or if they're in 7th grade, most of the heights of students are around the same. They're about within 2 inches of the median height. Now that you're finished, you can begin working on homework 15-5.